In this video, I'll be talking about graphing reciprocal functions, and a very simple one, and we'll be graphing f of x is equal to 1 over x. So we're going to try to find the domain and the range of this function, and before we can do that, we'll have to graph this function. So first of all, are there any x-intercepts? Well, we know that in order to find our x-intercept, we're going to solve our x-intercept, we must make the numerator equal to 0 and solve for it. Equal to 0 and solve. For example, say our numerator was like x minus 2, right, over something, 1. So for the x-intercept, we just solve and make the numerator equal to 0. So x minus 2 is equal to 0, x is equal to 2. But the numerator is a constant, and 1 cannot equal to 0, which means there are no x-intercepts. Okay, it's kind of messy. So how about our y-intercept? Well, we get our y-intercept by making x equal to 0. So we make the function f of 0 is equal to 1 over 0. So f of 0 is equal to undefined, so there's no y-intercept. This is because any number divided by 0, whether it's 5 divided by 0 or 200 or 2000 divided by 0, any number divided by 0 gives you a vertical asymptote, gives you an undefined, and I'll explain after. I'll show you on the graph. So let's look at vertical asymptotes. Vertical asymptotes. The vertical asymptote happens when you make the denominator, so the bottom part of the fraction, denominator equal to 0. So x equal to 0. The denominator is x, so x is denominator equal to 0, so x is equal to 0. So we know that the vertical asymptote occurs at x is equal to 0. Now, the horizontal asymptote, there's no such thing as a horizontal asymptote where the numerator is just a number, right? When it's a constant or just a number, just 1 or 2 or 2 million or 2000 or 500. So there are no horizontal asymptotes. So now we're going to start to graph this function. Okay, so we know, take another color. So we know that there's a vertical asymptote at x is equal to 0. So vertical asymptote x is equal to 0, which means that the function cannot cross this line. So let's plug in -1, -2, and we'll plug in numbers along these lines and to see what the graph will look like. So okay, so 1 divided by -1 is equal to 1 and is equal to -1, right? So that's the point right here. So the y will be -1, right? Because now we're trying to find the y point. So y is equal to 1 over -1. Y is equal to -1. Now we're going to do the same thing with -2. Y is equal to 1 over -2. Y is equal to -half. So it's decreasing, getting smaller and smaller. Now if you plug in, the greater the x number becomes, the closer it approaches. The closer it approaches. And actually I just realized I made a mistake here. When there's a constant on the numerator of a function, the horizontal asymptote is always y is equal to 0. I apologize for that mistake. So as I was saying, as the x values increase, the y value gets closer and closer and closer, right? Closer and closer to the x-axis, very close. And as the x values get smaller and smaller and smaller, you will see that the y values actually start to increase and increase and increase and increase. And I'll show you. We'll take a very small x value. So y is equal to 1, because it's 1 over x, so y is equal to 1 divided by 0.001, negative, right, because it's on this side. So what will our answer be? Well, let's see. 1 divided by negative 0.001, it's equal to negative 1000. So the closer and closer the x values get to the vertical asymptote, it just gets bigger and bigger and bigger. The y values get larger. In this case, they get more negative, higher negative numbers. So this will be this first part of the graph, and we can do the same thing on this side of the graph for the positive numbers. So we'll do this quickly. So the graph will end up looking like this, because if you take very small positive number as positive 0.001, you'll get a high y value, positive, very almost positive, positive 1000. And if you take a very great x value, so y is 1 over 10, you'll get a very small y value. So what is the domain? Domain is the x values, right? So the domain is equal to x er, right, such that you know, because we can, there's all x in this function is every single value except for the vertical asymptote, which is x is equal to 0. So x cannot be equal to 0. X cannot be equal to the vertical asymptote. Other than that, x can be any other single value. Because remember, any number divided by 0, as we found here, is undefined, which means that the vertical, and we found the vertical asymptote is 0, and no number at a vertical asymptote, the graph cannot cross it, which means that x cannot be 0. Now the range, well, as we can see, y can be any value, right? Because you see here on this graph, y can be from, it can be any value, because except for the horizontal asymptote. So x is every value except for the vertical asymptote, and y is every value except for the horizontal asymptote. So what's the horizontal asymptote? 0. So y cannot be equal to 0. Because look, y can be a very small number, it can be any number, any number, any number, any number, it can be any positive number, positive number, positive number, but it just cannot be 0. And same with x. And you can really write that as in a different way as the domain. I'll do this quickly, and I'll put that on the next video.